Great. Thank you, everyone, so much for attending today. My name is Debra Langer, Vice President of Business Development for Datasource Consulting. And you are about to listen to the presentation, BI Agility through Data Virtualization. Super quick, as I know everyone's time is very valuable and we want to get to the content. But I do want to share a little bit about Datasource Consulting, which explains how we are knowledgeable in this area. We are a business intelligence and data integration consulting firm. It's all we do. And because most BI programs fail due to the design and the architecture, a staggering 65% actually fail, our specialty has naturally evolved to this area. Similar considerations certainly relate to data virtualization. As a services company, we offer assessments especially for existing BI and data programs where there might be questions on scalability or performance, where users might be encountering latency or questioning the accuracy of the data. We can also evaluate environments to see if there is an appropriate business case for data virtualization. In addition to assessments, we also offer data architecture and design and builds from scratch, data integration, ETL, data modeling, data governance and quality, vendor tool evaluation, and of course, data virtualization. All can be considered critical components of a successful BI program. So quickly, some housekeeping. We have everyone muted, so I encourage you to utilize the chat for questions at any time during the presentation. Towards the end, we're going to have a more formal Q&A. The presentation, just so you have an agenda, is about 30 minutes in length. And I don't know about you guys, but I've attended and presented at many webinars, and I think some of the most valuable content is at the end, where people are asking questions, because so often many people have the same questions. And so to get those answers and have some dynamic conversation is really valuable. So please engage with us at the end. We'd love to be of help. So let's go ahead and get started. I would like to introduce Steve Dine, who is not only managing partner for Datasource Consulting, but he is also a faculty instructor for the Data Warehouse Institute. He's a BI best practices judge and a regular contributor to the BI scorecard. Steve?
Thank you, Deborah. As many of you know, and throughout my years, in fact, when I first got started in BI, programs or projects that lasted 12 to 16, sometimes 18 months, and there are a few that have lasted much beyond that, were commonplace back in the day. And as you know now, that's a lot less, we usually are willing to wait a lot less time for delivery of BI programs. And a big part of that is the fact that they can do a lot of it themselves. And the TWI report that came out a few years back explained it perfectly, and they did an empirical study and looked at how long on average does it take to deliver data warehouses and complex reports. And to no surprise, most of the answers were in upwards of 3 months. Some were below that on average, about 8.4 weeks back in 2009, were about 7.8 weeks in 2011. And complex reports, which were measured based on number of dimensions measured and user access rules, things like that, take upwards from 2011 about 7 weeks to deliver. And that's far too much time. And if you're involved in the BI program today, I'm sure you know your users are clamoring for information and it takes too long to deliver. But why does it take so long? Well, in my experience, there are a lot of reasons why it takes long, but a big component of it is the way that we develop. And we traditionally develop through waterfall methodologies we have in the past, and through development, test, and QA production cycles through multiple stages of landing and physicalizing the data. And this leads to a lot of time in development. In fact, from an ETL perspective, just getting data elements from request through delivery takes quite a bit of time, from the perspective that the users get started in day 0, and it goes through the development process through each of the layers of development. Then it has to be tested and QA'd, and then finally moved to production. At that time is when the users end up seeing it again. in the traditional development process, the big challenge is that it excludes the business, and anyone involved in BI today sees this regularly. The fact that the business, especially when we're doing waterfall methodologies, users are involved at the beginning, then the teams go off, develop data models, usually start with logical or conceptual models, and then through physical models, through the ETL design development across all layers of the data warehouse, start working on the front-end design development, and then the users review it. And so what that ends up causing is long redevelopment cycles, because not only does it have to continue to go through that process, but the vast majority of the time, by the time that work is done, either user requirements have changed or users look at what's been developed and say, that wasn't exactly what I wanted. And so we have to go through that long redevelopment cycle of adjusting and rephysicalizing, redoing the ETL, testing it, QAing it, putting it out to the users for front-end development, or building out the front end and getting in front of the users. The other challenge that we have is that we tend to lump all users together as if they were the same and all their requirements the same. So regardless of whether users have complex requirements or easy requirements, whether those requirements span across the organization or whether they're just individual contributors looking to do some analysis, we tend to treat them all the same way, and we treat them that way in our development methodology. So what that ends up doing is ensuring that regardless of how easy the requirements are or how fast it might be for an individual user, they get lumped into the most complex requirements, and they have to wait just as long as anybody where the requirements are more complex or span across a larger variety of areas in the organization. So the question is, what do we do now? And you've heard a lot about Agile, and I'm sure you probably overheard about Agile. So one of the challenges I'm sure that you've found if you've implemented Agile or tried to implement Agile is that not all the concepts of Agile apply to BI. And so we tend to use sort of the small a Agile versus the big A Agile methodology to refer to getting Agile. And for those that aren't familiar with Agile, really it's about building working through a preparation phase, whether through user stories or through more traditional areas of creating or gathering requirements. But basically come up with contractual agreements, understanding the vision, the product backlog, developing an initial release plan, getting stakeholder buy-in, getting a team together, and really what ends up happening is we create this production backlog, and then we get together and create sprints. And sprints are generally anywhere between 2 and 6 weeks. And in those sprints, you at the beginning determine what is it that you're going to deliver at the end of the sprint. So it creates very fast delivery cycles, and estimate how much work is required in the sprint, create a sprint burn down chart that gets updated each day in what we call daily scrum meetings, where we go through the team, both the users and the developers meet and discuss what got accomplished yesterday, what you're planning to work on today, if you have any blocks, and then discuss any follow-ups. So it's a very interactive process. And each day that sprint burn down chart comes down, hopefully in a linear fashion down to 0. That's the most ideal case. And then you can visually see how close you are to making your sprint. But for those that have implemented Agile, the natural question becomes, well, that's great that we're speeding up the process, but how do you actually deliver in 10 to 30-day cycles? And that can be the big challenge, because we hear a lot about Agile, but we don't hear, how do you actually enable Agile? Well, one way to enable Agile is through data virtualization. And for those that aren't familiar with data virtualization, I tend to like Rick Vanderland, who wrote a great book on data virtualization. I like his definition, but really I break it out into 4 areas to truly understand what it is. And one is that it's unified, meaning that you can funnel all your users through one access point. And the benefit of doing that for a BI program is the fact that not only do you reduce the number of different logins that you need to provide users, but you can start auditing and understanding what are users querying, how long does it take to get that data, and what are the areas that maybe need to build out in the data warehouse, and you can start using that as in essence, a requirements gathering process in some respects to understand where the real demand is. The second part is that it's abstracted, meaning it's not really dependent upon the source applications, the underlying applications or development technologies. And that's important because when we have different types of files, different types of systems, a lot of times it's a challenge to access those, whether it's through web services, whether it's just simply accessing XML documents, raw XML documents, or flat files, or trying to combine flat files with database technologies. It's important that we abstract it so that we give one layer for users to be able to work with it without having to worry about all the different ways to access it. Third is that it's encapsulated, meaning that all those structures and business rules and relationships, different data types are hidden from the consumers. And for those that work in front-end BI environments developing semantic layers, this is something that you've worked with and done for a lot of years. This is just really pushing it down into the database layer, and the benefit of doing that, or at least the data virtualization layer that is, and the benefit of doing that closer to the source layer is the fact that anyone who accesses the data virtualization layer has all those rules, all those joins, all those structures, relationships, everything already defined for them. So we're in a lot of environments what we find is consistently putting the same business rules, the same metadata, defining relationships multiple times in different business tools or different BI tools. Instead of doing that over and over again, you can save a lot of time and become a lot more agile by putting it in one place, and then all the applications and all the users that access it all have access to those same rules. Lastly, that it's heterogeneous, and this is where really data federation, and by the way, data virtualization for all those who have been around a while has gone through a number of different incarnations. It started out as data federation, then it sort of changed the name or changed what they called it to EII, which stood for Enterprise Information Integration. And now the third incarnation is really data virtualization. Aside from the technologies becoming a lot better, really the concepts haven't changed a great deal. But the heterogeneous part of it is really that we're accessing not only different systems, but different types of data at the source layer. You know, like I mentioned before, it could be a cube, or it could be a flat file, it could be Excel spreadsheet, it could be a relational database, it could be an analytic database. And really all that, data virtualization helps bring all that together. But sometimes even the most important part of understanding data virtualization is that it's not a replacement for the data warehouse. And this is where, from my standpoint, data virtualization vendors really suffered in the early years of what was called data federation or EII, is they tried to sell it as a replacement for the data warehouse. And those involved in data warehousing quickly started realizing that, I mean, aside from certain speed issues, which was related to just immature technologies. Also, you couldn't really go out and capture all the slowly changing history and keep a non-volatile environment, which you need for data warehousing. So data virtualization from an architectural perspective, for those that aren't familiar with it, really there's a number of different data virtualization tools out in the market, but they all share sort of a somewhat common architecture underlying, meaning that there's usually a protocol layer that sits between the sources and the data virtualization layer to be able to access all the different types of sources it needs to go after. There's a data access security layer, which provides those logins to each of the different systems, but all through one system or one layer. Then there's a query engine that, just like within databases, many of them have cost optimizers, and that engine tries to determine what's the best, most efficient way to bring that data together, filter it, join it, and return back the results. There's also cache engines, and the cache engines are very important because for performance reasons, it can really enhance the performance of data virtualization technologies. For systems that don't change very often, you can cache the results so it doesn't have to do a query down to the data source level each time. But more importantly, and I'm sure in your environments, your source operators don't like having people going directly against the source systems. And so this is one way of insulating those queries from those source systems by maybe doing it once a day or a few times a day, where the data can be cached and provided to the users and it's not consistently hitting those systems. There's a metadata layer where you create those semantics and business rules. User security access layer where you can provide access to the users where they get into the data virtualization environment, and then a protocol layer where the end user tools or the BI applications interact with the data virtualization technology. How does it work? Well, provided a couple of examples just to give you an idea of how data virtualization technologies work. starts out, if you're, for instance, using a query tool and just querying against the data virtualization layer, you might be doing a select query right from your query tool. That's issuing a query that goes into the data virtualization architecture, pushes it out to the sources, the queries out to the sources, brings them back into the data virtualization layer where the results get joined and filtered in a lot of cases, and then brought back to the result. The resulting set goes back to the tool. Maybe you're accessing it from a dashboard, and the dashboard is querying multiple different systems at once. Similar, of course, there's a query. The query goes down to the sources, whether it's in the cloud or on-premise. Brings that data back, in some cases, brings it into a source database to do the filtering to make it more efficient, and then returns the result set back to the dashboard tool. So it's very efficient because it can bring data not just from multiple systems, but multiple systems across multiple queries. So it can issue all those queries and bring back the data homogeneously back to your requesting application. But in the end, really what data virtualization looks like is a database. And so those are accessing it directly. It's just as if you were accessing a SQL Server environment, or maybe you're accessing an Oracle environment, or anything that you used to, any database technology you used to interacting with. But it could also be published out as a web service, and so the consumer might be actually querying a web service. Those web services are actually going and issuing the request to the data virtualization layer and then returning the result sets back. An important part of creating a efficient data virtualization solution is implementing an enterprise semantic view. Now, as we're going to talk about later, not everything has to be an enterprise view. However, what this does is provide that layer of abstraction between the source application, abstraction and encapsulation between the source data and the results. So when the users look at it, they get one consistent view of data, whether or not it's coming from TISA, or maybe it's coming from Oracle, DB2, or a flat file, XML, or even a cube. So provided a few use cases just to give you some ideas of how data virtualization can be used to make your organization a bit more agile. And one is the case of the Augmented Data Warehouse, which is something that I did years and years ago, and years being about 10 to 11 years ago, back when I was director of data warehousing for a manufacturing company, and I was responsible for a BI environment that was enterprise-wide, and we were responsible, obviously, for maintaining the data warehouse, as well as all the front-end reporting tools. And when we would receive requests for data elements being put in the data warehouse, obviously that takes a fair bit of time. We started realizing, boy, you know, everything didn't have to be done through ETL. And so what we did is we actually used data virtualization technology to virtualize a lot of the queries. And back then, obviously, it was a lot higher cost to do that. But we found that a lot of the requests were one-off requests where users wanted data that was brought into the data warehouse. They would do a query on it or run a report on it. And maybe that report got run once, or that query got run once, or maybe it only got run once a month. And for those cases, we didn't have to necessarily do ETL. And so in the case of an augmented data warehouse, you can bring that data into a source layer or an import view, and then build out a business view of that, and then really just bring elements from each of those different systems into and combined in with maybe your customer dimension. And that's what we used to do. We would actually use data virtualization to augment our dimensions, and sometimes our facts, but mostly our dimensions for things that we just either thought weren't going to be used often, or maybe only got run once a month or sporadically. And it saved a lot of time, We were able to develop and test and put those elements out there within a day. In fact, sometimes it only took a couple hours, rather than going through a 1 to 3 week cycle to try and build it into our ETL process and then push it out to production. Second use case is building out virtual data marts. And in this case, you could be accessing your enterprise data warehouse and spinning out virtual marts rather than physicalizing them. And this is very important because we spend a lot of time spinning out data marts, and a lot of times for different business areas. In fact, we have a client now that was spinning out a lot of data marts, just one for each different division, because they look at the data slightly differently. So you can leverage data virtualization technology to build those views to provide those different aspects to the data that may not be greatly different, but may be different enough that you would have to rephysicalize it if you're going to spin those data marts out by division. You could also use security to limit access by different views so that essentially they feel like they're looking at their own data mart. And then from an operational reporting perspective, you could build, you could point your data virtualization technology directly to your source system. Best practice is in essence putting it against a replica, because obviously we don't want to have too much volume going against our source systems for analytics style queries, or even sometimes transactional queries for that matter. But you can build data virtualization layer on top of your transactional system or the replication of your transactional system and provide very quick reporting out through your BI tools if you like. And the benefit of that obviously is reduced latency. As many of you know, when you put it through your ETL architecture, there's just a certain amount of latency that's involved. But also every time you take a step away from, every time you land the data, you're essentially risking data quality. And every time you land that data and reprocess it, you have that chance where you have some data quality challenges. With data virtualization, you're not physicalizing that data per se, and if you are, it's just a cache layer that's very consistent. You can provide much more consistent views of the data on your operational side. So key strategy from data virtualization perspective is to understand that not all users are the same, and not to just try and develop because that they're assuming they're all the same. Because one of the challenges obviously is that individuals have different requirements from a departmental side, which have different requirements from an enterprise side. And if you're developing all the same way for all your different users, that can obviously delay the time until you deliver. So from an individual perspective, if you're going to leverage data virtualization, you can limit the requirements out of the gate. You could provide them one layer, which is you can just expose those tables, provide some metadata that you can add onto the virtual layer. You can enable sandboxing and then use those results that the users, as they're using that data, use those results as an input to departmental enterprise solutions. From a departmental perspective, you can group the requirements, provide two layers, a stage and presentation layer. You can enable shared sandboxes and then standardize the rules where you're now starting to add more work into developing those layers, but you're providing standardization as you have more users accessing similar views. And from an enterprise perspective, you can add integrated requirements, provide 3 layers, as well as standardizing the rules and limiting redundancy. Because one of the challenges with being agile with data virtualization technology, and right now it's an area where the vendors haven't done a great job at creating reference architectures from a data modeling perspective for virtualization technology. And from that perspective, it's a little bit more like object-oriented modeling versus relational modeling, from the perspective that you want to encapsulate as much as you can in each view and not have business rules, the same business rules spread across multiple views, because when you have changes, then you have to track down each place, each view where each of those rules are being defined and make changes in multiple places. So the more you can limit those rules and standardize them into common layers or common objects within the data virtualization layers, at that point you can really start to insulate from change, and you can limit the amount of work it takes to actually make changes in your environment. That's a big part of becoming agile, which is you have to be able to move quickly. And so utilizing data virtualization isn't just about grabbing a tool and providing quick access because you have a data virtualization, you have to land the data. You do have to think about how you're going to architect it, but you have to really think about how you're going to divide up each of the requirements to ensure that each of your constituents is getting data as fast as possible, but you're not creating so much work that you can't make changes in your environment. So stratification can be a very valuable tool to achieving that. So why now on the data virtualization side? Well, obviously we've had increases in CPU and disk memory, system buses are faster, networks are faster, so it's really enabled data virtualization to be efficient and fast. Decreases in cost of memory to be able to store more memory in data virtualization cache layers. We've had increases in effectiveness of query optimization from a data virtualization perspective. A number of the vendors are very good at pushing those queries down to the databases where they can, so that more of the processing is happening on the database platforms versus happening in the data virtualization technology. And it's important because the more data that gets returned into the data virtualization server, the longer it's going to take. We've had increases, obviously. We've had a lot of cloud systems out there. We have more and more numbers of different sources to go after. So data virtualization is now becoming important technology and providing the ability to be more agile. Data virtualization also provides the ability to prototype a lot faster. So you can get data out into your front-end tools. Think about all the time we spend generating test data because we don't have any data in the data warehouse yet. You can actually start modeling those presentation layers in data virtualization technology, and you don't even have to have the data available in your data warehouse yet. Users or front-end report developers can start building front-end reports or semantic layers, get that information or those reports out in front of the business very, very quickly while the data warehouse is being built. So it can be very fast at creating prototypes. But it's the last piece and the last bullet that I did want to discuss is that obviously users aren't willing to wait for data integration solutions. And the reason why, from my perspective and what I've seen out in the marketplace, why it's becoming such a bigger challenge today than it was in the past is because there's just more ways for users to do it themselves. They can go after, they can download open source tools, do a data integration and access databases if they want. They can subscribe to cloud technologies and implement BI platforms out in the cloud. They can bring in systems like Tableau and QlikView, which are desktop analytic tools. And obviously the big challenge with that is eventually it ends up on the BI program plate. And they become very, very challenging to manage when they weren't developed internally through the BI program. So some Agile lean benefits. Obviously, you can create a single semantic layer, which we talked about. You can maintain a single security layer. You can reduce your QA effort since data isn't being physicalized in multiple places. You have one place you can audit usage and performance. Enable changes of underlying source systems and insulate from those. You can deploy sandboxes. Obviously, change detection and impact analysis you can automate. And you can limit the number of ETL schedules and jobs that you have to monitor out in the environment. So I know we had to run fast through that. So there's probably a few questions and things that have come up. I wish we could spend more time talking about it. Actually, this is part of a much larger presentation that we do on data virtualization. But it's really more of an introduction and understanding of how data virtualization can be used to enable Agile. So if you have any questions, please feel free to type them into the chat window. Deborah, I'll leave it to you from here.
Great, yeah, so we'll give people a couple of minutes to type their questions in. In the interim, I had a quick question. How does data virtualization handle data quality?
It's a great question, and depending on which solution you employ, they each have slightly different way to enable data quality. I would say that Informatica probably has the best, or at least most integrated solution for data quality, in that you can plug in their data quality components into their data virtualization, or IDS, they call it, Informatica Data Services, into their flow. So you can actually provide enhancement, match, merge capabilities, data validation through their technology. Tools like Composite and Denodo provide functions that you can use to do match, merge. I would say Denodo probably has a larger group of functions for doing match merge than I've seen in Composite, but they both enable the ability to do it. And you can actually call web services from each of the different tools to, if you have an address cleansing service, things like that. So you can employ data quality through data virtualization. Obviously, it does add overhead to the process, so you just have to be careful about your performance.
Thank you so much for that answer. If you don't have any other questions, then I've got another one for you.
Sure.
Okay, very good. So how does data virtualization differ from data federation tools?
They really don't. And I say they don't, but so back in the day, data virtualization was really called data federation. It was sort of a data federation tool. Now, having said that, they do get confused because there are data federation tools out in the marketplace that aren't necessarily what I would consider data virtualization per se. For instance, DB2 has the ability to actually bring mainframe components like IMS databases together and consolidate them into one place, which is enabling data federation. And there's also a few other tools in the market that do that. So it's a very subtle difference between the tools. I shouldn't say subtle. The tools are very different, but from a definition perspective, really data virtualization tools today get lumped in with data federation.
Right. Okay. Thank you for that. How does data virtualization fit in, let's say, like a service-oriented architecture?
Well, data virtualization is actually a great way to help provide web services. Now, service-oriented architectures are a much larger undertaking of planning out your architecture and what services are going to be provided. But what data virtualization does, it enables you to take your views essentially and spin them out into web services very quickly. And so you can actually provide web service access through the data virtualization layer back down to the sources very easily. You can control changes and abstract them very easily, and you can spin out the web services very easily. So it helps enable an SOA. I wouldn't say that it is an SOA, but it does help deliver. And SOA is a much larger topic, but it is complementary.
Okay. Very good. Thank you, Steve. We've had some questions come in. Let me ask the first one for you. Do you see data virtualization as a primary discovery method for eventual ETL rules, or in some cases, DV solutions persisting as production BI applications?
There's a mouthful, but if I'm hearing the question correctly, the answer to the first part of that is absolutely. Using data virtualization as a discovery platform, we talked about prototyping earlier, but to use it as a discovery platform is one area where it has a lot of strength and can really help enhance the BI program, because you can provide access to the end users before your data is even modeled. You can provide them access to an import view. They can really get in and start working with the data very efficiently, very quickly, and start pointing out areas of discovery and understand what the data is. But, speaking from a larger context where we have a number of tools now in the marketplace we call desktop analytic tools, which are really discovery tools. Tools like Tableau, tools like Spotfire. They're very powerful. They provide the ability to do discovery very easily, but it's not easy to bring data into those tools when the data isn't very normalized. And so they work best, those tools generally work best on sort of large, wide tables. And what data virtualization can do is provide that in the form of a view very efficiently and enable those tools for discovery. And so if you're looking at deploying large-scale Tableau or large-scale Spotfire, and there's a few other tools like Biz2 out in the marketplace where you have very strong visual discovery, data virtualization can enable those tools very, very efficiently and very well. The second part is, do you see it? I think the question was, do you see it potentially being production BI application? The answer is yes. Some you'll find where you'll just build reports that just that are coming directly through the data virtualization layer out to operational systems, sometimes joining with a data warehouse. You may, in some cases, and there are use cases where data virtualization technology is being used on top of a data warehouse as a pass-through, just to consolidate all the access and spin out web services very easily for an enterprise data warehouse. So in a lot of cases, the data virtualization layer is actually the production environment. In some cases, it's used alongside it, but it can be used as a production BI application, absolutely.
Great, thank you, Steve. We've got a couple more questions that have come in. Question number 2. In the augmented data warehouse case study that you shared, number 1, the first scenario, do you recommend distinguishing to the users data elements that have come through the formal data warehouse process from those that arrive via a DB process?
That's a great question, and that's probably more of a philosophical question potentially. From my perspective, and the holy grail, I guess, for as long as I've been in BI is, really, you want to make it transparent to the users from the perspective that they really shouldn't know or have to worry about where the data is coming from. When a user issues a query, they should just be comfortable that the data is coming. It's accurate, it's correct, and it's exactly what they want, what they are going after. Having said that, we don't have an ideal world. So yes, the best thing is to provide lineage and metadata to have the users understand where that data is coming from. In some cases, you can use naming conventions for the tables as well as the data elements to help provide lineage as to where those data elements are coming from. In other cases, you can provide a metadata portal to help users understand where that data is coming from. And then the best tool I've seen for providing lineage, and I haven't seen Composite's new version, and I've heard that they're providing that ability, but I know Denodo provides very user-friendly interface for users to go in and trace back the lineage of where the data that they're accessing is coming from. So ideal world, you wouldn't have to. In the real world, you do. And to be really successful in data virtualization, you need to be able to provide that context to the users.
Great, thank you, Steve. Question number 3, how does an organization get started building semantic models? The focus in the past was on relational models, which are more database-centric.
Can you repeat that? Sorry, you cut it out at the end there.
Absolutely. How does an organization get started building semantic models? The focus in the past was on relational models, which are more database-centric.
That's a great question, and it extends beyond data virtualization for sure. But there's a whole class of tools out there now that are lifecycle management tools, and really they provide the key and understanding for how to get started with, with semantic modeling. Although, having said that, part of a good data modeling process starts with building out conceptual models and logical models that are very much business-driven. And a good data architect, a good data modeler, will create a logical model that essentially, in a lot of ways, mimics the business and what the users need to see at the end, because it's in business terms and it's in business context. And so, generally, the way I start with a semantic model is through a logical model. And you start looking at those logical models that were developed during the data modeling process and use those as a context for how business looks at data. And then throughout your Agile iterations, leveraging that logical model to then start working with the business to refine it into a semantic model. And depending on which tools you're using, whether it's a data virtualization tool or whether it's a front-end BI tool and you're building a semantic model, the best way to build that semantic model is entirely tool dependent, because some tools like MicroStrategy provide a lot better function, or at least a lot deeper functionality for custom grouping and being able to query across different types of groups and summation subsets than other tools out in the marketplace. And so modeling for those semantic layers is a little bit more involved. But having said that, I generally start with conceptual or a logical view, a logical model.
Great. Okay, so we have 4 more questions that have come in, and we've got about 4 minutes, so we'll kind of zip through these quickly, if you will, Steve. So next question, this is got 3 parts. What are the names of enterprise architectures based on data virtualization? Are they synonymous with logical data warehouse in terms like that? What are the differences?
That might need a little clarification, because enterprise architecture is a pretty broad statement. There's a number of different enterprise sort of data architectures or enterprise architectures out there. There's the Zachman framework. There's TOGAF. There's a whole bunch that have been defined over the years. And so it's a pretty broad question, but how you decide to create an enterprise model is entirely dependent upon sometimes which camp you belong in, but really, from my perspective, it's one of those where you have to take, even though you're taking a global view, you have to implement locally. And so you want to take a global view in creating an enterprise model, but you also want to enable things locally and not have to wait those long periods in getting everybody to agree on terminology, getting everybody to agree on, business rules, getting everyone to agree on data structures. So while, the enterprise frameworks are very powerful and they can be used absolutely to start, looking at building enterprise models, you have to do that in balance with implementing, at much smaller levels. Keeping in mind that, the overall goal is building an enterprise model, but that takes quite a bit of time.
Okay, next question. How would you address the need for surrogate keys in a DB solution where, for example, customer_IDs are not unique, singular, or stable across sources?
Can you repeat the beginning of that question?
You bet.
Please.
How would you address the need for surrogate keys in a DB solution where, for example, customer IDs are not unique, singular, or stable across sources?
Well, that's a great question, and that speaks a little bit more to data modeling, but with the context of data virtualization. And it's important to have unique identifiers. Now, obviously, a good surrogate key is one that has no meaning to it. So, users in general don't understand surrogate keys. And if you're surrogate, one of the tests often for surrogate keys is there any meaning behind it? And if there is, generally it's not a surrogate key. You need to take into account that you have to have, obviously, some way for users to query data virtualized views to get back unique results. And so in some cases, it's a matter of taking natural keys and including a source system name. In some cases, it's taking a natural key and providing some prefix or suffix onto the natural key. There's a number of ways from a data modeling perspective to go about creating uniqueness, but you do have to take into account that, as users or BI tools are querying data virtualization technologies, they need to be able to get back unique records. So in your approach, you have to make sure you're providing uniqueness beyond a surrogate key. Now, surrogate keys are great for as you're designing your physical models and creating fast joins. Most database technologies leverage fast join technologies, or at least faster, more efficient joins using things like surrogate keys. Depending on which database technology, there's different methods to employ them. But from a data virtualization perspective, it's really, from my perspective, about being able to provide uniqueness.
Great, thank you. What tools do you like for metadata management portal?
I wish I could say that there is a dominant player on the market that is ubiquitous across the industry, but it's not. The challenge we've had around metadata management is that the enterprise tools like Rochade, they're great. They have unbelievable amount of functionality, capabilities for data lineage. Really, it's an enterprise governance platform, but they're very difficult to deploy because of the enterprise focus and getting enterprise agreement, but also because there's so much capability that it requires a fair bit of training. But there's a number of tools out in the marketplace. Generally, a lot of organizations and people sometimes are going to jump up and say, what are you kidding me? But a lot of organizations use SharePoint, and they build a consolidated portal in SharePoint, provide some glossary and definitions, and then have hooks into their BI applications. We've built a lot of them through the front-end BI portals like MicroStrategy and Cognos, and added a lot of metadata through there and created glossaries, added videos, things where we can create an enterprise portal. There's some third-party portals out in the market like Liferay that you can use to customize and create, pretty strong solutions. There's couple open source portals out there from a metadata perspective. And there's some newer tools in the market. I can't think of the name of it off the top of my head. I can't think of the name off the top of my head that provides a nice glossary that you can use, as well as it provides lineage, and it doesn't have so much capability like some of the enterprise tools that enable you to do that. But quite honestly, the best portals that I've seen have been ones that have been custom developed, either using like a LifeRay or built into a custom solution in one of the BI portals. And in some cases, as much as it's not a solution for enterprise data management, usage of tools like SharePoint, can provide that one place for people to go to, that you can provide glossaries, and you can actually provide workflow and ways to manage metadata. It's not an enterprise solution by any means, or at least an enterprise data governance, data management solution, but it can provide a lot of capability.
Great. Okay, I think we've got time for one last question, and then we're going to switch to the next slide. Does a logical data warehouse include operational data?
That's a good question, and quite honestly, logical data warehouse, from my perspective, is sort of come out as, I think the first time I saw it was from Gartner, and I don't know if it was something that came out of Gartner or not, but the question of what's a logical versus a virtual or whatever your physical data warehouse, I mean, there's a lot of ways to get to a logical warehouse. Back in the past, logical warehouse was, we're going to physicalize a bunch of normalized data structures, and then we're going to provide views on top of it, and that's going to be a logical warehouse. And we're going to build those views as much, in the form of a star schema. Nowadays, obviously, there's different ways you can achieve that. From my perspective, yes, logical warehouse should include operational data. And like I said before, at the end of the day, the user should, ideally have one interface to go through to get their data. Some of that data might be coming from operational systems. Some of it might be coming from the data warehouse. You need to have a way for them to understand what the difference is. But I think the ideal logical warehouse, quite honestly, is providing low latency data, as well as data that's stored, aggregated in a lot of cases, and provides history. In the future, it's going to be blended from my perspective, and that's where the future is going, which is that consuming applications are going to consume them probably in the future, the vast majority, through some sort of service layer, and they may not know where that data is coming from. But logical warehouses have been sort of dogged in the past because I think they've been implemented incorrectly, and also you got to be very, very careful of workload. And you got to understand what your workloads are when choosing what kind of architecture you're going to employ, because there isn't one tool that fits every need out in the marketplace. And that's the biggest challenge, is the vendors are very good at overselling their capabilities. And so people generally architect, put all their eggs in one basket, and then all of a sudden they end up with operational workloads on an analytic database, and they're not, all the requests are getting queued up into threads, and people are waiting around behind, because they're inefficient workload management, and it doesn't work for them. So, the right solutions as we move into the future are going to be workload-based architectures, which most likely it's going to be a combination of different solutions.
Great. Thank you so much, Steve, for all of those answers. If we can just click through the next slide, we'll close this out. If there are additional questions that, maybe you didn't get answered or that you think of later, this next slide is going to detail our contact information. So feel free to reach out to Steve or I at any time. Happy to get those answers to you. And upcoming, our next webinar is going to be November 21st at 2 o'clock Mountain Standard Time, same window of time. And it's going to be Predictive Analytics Demystified. It will include suggestions for initiating advanced analytical techniques in your organization and how to avoid common pitfalls. So I hope that you will join us for that. And there is the link to register. You can also just go to our website, which is www.datasource www.datasourceconsulting.com. And over on the right-hand side, we have our events listed, and you can just click on that and register for the upcoming webinar. So I hope that you'll join us in the future. So lastly, again, I'll send our contact information, and appreciate your time, and would love to work with you. If you have any questions, please reach out to us. Steve, any closings?
Nope. Thanks everyone for coming. It was, if you have any additional questions, as Debra mentioned, feel free to reach out to me directly or to Debra. And you know, even if you don't have an enterprise-wide initiative for data virtualization, it's one of these technologies you can get started small and just try them out in your environment, because it's really sort of a great tool to have in your tool belt.
Great. Thank you everyone for attending. Have a great rest of your day.